So welcome to day one of my Inventor IO 30-day Lost in Space journey. As you can see, I've taken the board out of the electrostatic bag. I've got the breadboard next to it. I took out the USB cord and I'm ready to get started. The Inventor IO website offers all of the tutorials online. So what I'm going to do is I'm going to watch the tutorial, I'll assemble the board, and then when I write the code, I'll write the code on my computer and I'll show you as I'm doing it how that's done. I am not going to play the videos or any of that stuff, only because if you buy this kit, you get access to the website, and all that would be doing is just rehashing the same thing over and over. So I'm just going to assemble, code, and then we'll reconvene and we'll see how everything works. All right, this is a little more familiar. So what I'm going to do to get started, I'm going to go to the Inventor IO website. I've already created a login. I wonder if you can guess what my login name would be. When you go to the Inventor IO website, you can see that there's different training courses that they offer. They have this Hero Introduction Training, Sensor Training, Shields Training, and a shield is just a circuit board that plugs in over top of the Hero board or the Arduino boards. Invent You, our 30-day Lost in Space adventure. The Hero/Arduino simulator, which looks like it allows you to build circuitry in a virtual environment instead of actually having to plug things into your breadboard. I've only created a login. This is the first time that I've been on this portion of the website, and so what I'm looking at is as new to me as it is to you. But knowing that I have to get into the 30-day Lost in Space, I'm going to go into here. We can see it backfills all my information. I'll say I've agreed to the website terms. And I just want to read through this with you and we'll see what this is all about. So it says, are you ready to start your challenge? 30-day Lost in Space. So it says right here, this is a 30-day journey that teaches you coding and wiring through problem-solving, mission-critical challenges. Learn to write code and wire your own circuits. The purpose of this training is to show you some of the seemingly unlimited uses of the Hero board, which is the little Arduino board that comes with the kit. Creativity is strongly encouraged throughout the training, and you should always try to experiment with your own project ideas. So as I create circuits and I get more ideas for different variations of the tutorials, I'm going to go through and try different things, and I'll be sure to record that and put that onto the lessons as well. So in this course, we will learn how to write C++ code and use the Arduino IDE to program our board, how to wire circuits without breaking any components. That's an important thing. How to create your own security system, how to save hours of coding by using open source libraries, graphic and UI design using an OLED panel, game design using embedded engineering, stenography, and how to encrypt secret messages, and many more. So this seems like an exciting little thing. You know, it comes with a lot of little gadgets and gizmos, and there's also additional kits and things that you can buy to add on to your existing kit, or you can buy multiple kits. The Arduino boards themselves, the controller boards, if you look those up, they vary in price. They're $15, $30. You know, they're not super expensive. So it might be useful to have one or two laying around. I know that there's a lot of people in the Linux CNC community that are using Arduinos for basically smart relays, if you want to call them that. They're programming logic within the Arduino environment, uploading it to the microcontroller, plugging in the Arduino's I/O, and they're using them for various things. You fire an output from your board to the input on the Arduino. The Arduino is running its little process, and whenever it gets the input signal, it does what you tell it to do. So it's kind of like a smart relay. You're sending information to the microprocessor. The microprocessor does what it's programmed to do, and the output is what you're intending it to be. I know a guy that used an Arduino to circumvent the relay logic on an MCO PC Turn 55, very similar to the one that I have. Instead of doing that, my goal was to learn ladder logic and implement it that way, but that's just one of the ways that you can utilize this technology. Once you learn how to program the stuff, you can use these microcontrollers to do a lot of things. There's people that are using these to build small robots and things. Those battle bots, I'm sure, are controlled by microprocessors in some way, shape, or form, or they have a lot of microprocessors inside of them with sensors and things like that. So that's why I thought that this was an exciting little project, an exciting little adventure for everybody. And we could all kind of figure it out as we go along. So let's get into the 30-day Lost in Space challenge. And like I said, I'm going to sign up for it. I'm going to watch the video. I'm going to do the exercise. I'll explain what I did in the exercise, but I'm not going to rehash anything. I'm not going to try to reinvent the wheel. These guys are professionals. They know what they're doing. They are probably well versed in explaining this to you way better than I am at this moment. So let me get into my portion of it, and I will be back. All right, so I've gone through the first couple of pages, the introduction, and then I got into the first day. I'm not quite done with the video yet, but I kind of get an idea of what they're aiming towards. They're aiming towards the proverbial hello world, which is the very bare bones basic of any programming language that you are going to learn. The first thing that every language has you do is what they call the hello world program, which is where you define the very basic functionality of the language and get an output result. So in my case, what I've got is I've already installed the Arduino IDE. I installed that last week. I was playing around with it a little bit. But what I have here, and if you follow the instructions on what they say on the website, you'll get to this point just as easy as I did. I installed the Arduino IDE last week. I've just plugged in the Inventor IO Hero board. Under Tools, under Port, I verified that my port was correct. When I plugged it in, it automatically found the port that it was plugged into, so the port was already there for me to select. And then the board defaulted to the Arduino Uno, which is what the Hero board is based off of. So all of that was pretty much set up for me. Everything else is basic setup from the Arduino IDE. So to get started, it was pretty simple. I just started a new project. And anytime you start a new project, you'll get this void setup and this void loop. And the void setup is a one-shot area that the code reads. It establishes whatever is inside of this setup area or this setup function. And then it goes down into the void loop section, which is a looping function. And if you're familiar with any kind of programming language, this is essentially a while loop. So while the condition is not met, loop, 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 and continue to loop until the condition gets met. In the case of the void loop, there's nothing in here to terminate it. So this is an infinite loop. Anything with a double slash in front of it is a comment. This is a single line comment. A slash with a star is a multi-line comment. And then you would put your information inside of here, go to the next line, next line, next line, and then you would terminate it pretty much the same way. You would do a star and a slash. So anything inside of this area here, you'll see turns this light blue. This gets ignored by the IDE, and it doesn't get compiled and sent to the board. So I'll get rid of that. The first day lesson, all it had me do was trigger the internal LED on the actual hero board itself to blink. And to do that, if we look over here, I already have it written out, but just for good practice, what it had you do is establish a pin mode. Now the words that are inside of here, all the functions that you call up and all of the variables and keywords and things like that, they're all case sensitive. So pin mode with a capital M is different than pin mode with a lowercase m. You'll see that when you actually type in a word that the IDE recognizes, it changes the color to show you that it's an important keyword in the environment. Same thing goes with LED underscore built in. When I type that in, as soon as it sees that it's LED underscore built in, it automatically turns that to a blue. And then from there, we want to establish the LED as an output because it's going to give us a physical result. It's going to give us an output. If it were taking in information, it would be an input, but in this case, it's giving back information, so it's going to be defined as an output. And really, that's the only thing they have you do, is they have you set the built-in LED to an output. And then inside of the loop, we're just looping the light to turn on and off using the digital write command, which again, if we look on the left, digital is all lowercase, capital W, and then lowercase RITE. So digital write. And again, if I were to do it in lowercase, it doesn't change it to that orangey red because it's not the defined keyword. So in this case, we'll say digital write LED built in. And the first thing we'll do is we'll turn it on. So we'll set it to high. And in this line here, we have digital write. So we're saying, okay, we're going to write digital data, which is a 0 or a 1. It's either on or off. The name of the output that we assigned up here, which is LED underscore built in. And we're going to set that to high, which turns it on. Then underneath there, we'll put lowercase delay, which is another built-in function. And inside of the parentheses there, we'll say 500, which is a half of a second, because this is all in milliseconds. So 500 milliseconds is half of a second. Every line that you complete, you terminate with a semicolon, except for when you have open and closed curly brackets. So in the case of this loop here, we would have void loop, and then we have these parentheses here, because inside of the top of each function, you can also put in arguments inside of here. And then we have a curly bracket to open up the function, curly bracket closes the function, And then inside of these curly brackets are the pieces of code that get executed within this function. That's about as much as I know about C language programming, but at least I could fake it enough to show you guys what I'm doing. So from here, I'll do another line with a digital write, LED underscore built in. And I'll set that to low, which turns the output off. And then again, we'll delay for half a second. So if I close out the IDE that I had open before, and I go to Sketch, Verify Compile, it'll ask me if I want to save the file. I'll hit Save. It'll then compile the sketch, and it'll tell me if I have any kind of error messages at the bottom. So if I change that to from low to, say, low with a lowercase l, and I try to compile that, it's going to come up and say that there's no declaration of the word lowercase l, capital O, capital W. Again, because it's case sensitive and it's looking for that uppercase low, so that when I compile it, it's now happy. But you'll see that if you put something in wrong and you go to compile, it's going to tag the line that's wrong, and it's going to give you a little explanation at the bottom of what you did wrong in your code. Same thing with if you miss a semicolon, it'll tell you that it was expecting a semicolon before the digital write. So I'll compile this. I'm ready to send it to the hero board. So I'll do an upload, which will send the information, and the LED light will blink. So I'm going to switch back to the overhead camera, and I will show you my day's progress. So like I said, I've got the board plugged in. I've got it plugged into my computer over here. You can't see it, it's off camera. But we see right here we have the blinking LED from the little sketch program that we made. The programs in the Arduino IDE are called sketches. So the sketch that I wrote blinks the LED every half a second, half second, half second, half second. If I wanted to change that, I can tell it to set the light high for 3,000 milliseconds, which is 3 seconds, and then leave it off for 5,000, which is 5 seconds. So I'll just recompile. I'll re-upload. You'll see that it takes the information, it compiles, there's the lights blink, there are some, there's an RX and a TX light that flash to let you know that the serial communication is taking place. And then from there you can see that the LED is now blinking at a different rate. It's staying on for 3 seconds and it's going off for 5. So that's pretty exciting. It's nice to see that the setup was fairly straightforward. It was no more difficult than plugging in USB cable to a digital camera or something like that. You just plug in the device, you load in the software, you select the port that it's attached to, and then from there you can set up and transfer your data to the hero board. And you can start right away making your programs and making changes and seeing progress on the very first day. So I'm pretty happy with that. So this will end my day 1 of 30 days lost in space. And if you're interested, again, please feel free to pick up a 30-day lost in space kit and follow along, because this is going to be pretty exciting. I do intend on expanding on this in the future. I'm going to get through the 30-day lost in space, but then I'm going to definitely consider more of the content and more of the components that they offer. So, again, thank you for watching. If you like the content, please be sure to like and subscribe. If you want to buy me a cup of coffee, feel free to drop me a buck or two on my Patreon, and I will be forever in your debt. Thanks again. See you soon.